All right, so we have a question here for AP Calc on finding the derivative using the limit definition. So I'm going to go ahead and use this one here, and we're going to evaluate the derivative at several different points. So since it's going to just be the same function, and all we're just doing is changing the number, then it would be best to just find the general derivative rule and then plug in the number afterwards. So that's what I'm going to do and start off here with. So I'm going to, let me get the values first before I start. So we have 2, -4, 0, and pi. So I'm going to put that here on our whiteboard. So at 2, -4, 0, and pi. So I'm going to first start with getting our general derivative rule using the limit definition. So f of x plus h. So that would make this be 5 of x plus h plus 1. Okay, so I'm going to put this in brackets just to signify this is our f of x plus h minus f of x all over h. So this is our f prime. Okay, so I'm not plugging in the x value. I could if I wanted to, but then at the end I would just get a specific answer each time. I want to just get the general answer so I can then just plug in the numbers afterwards. So now moving forward, well, I can go ahead and I'm going to distribute the negative. So I have 5x plus h plus 1, and then we have minus 5 over x minus 1, all that over h. So already I can cancel out the 1s. I'm going to do that. I'll rewrite the limit down here. And now I have 5x plus h minus 5 over x all over h. So next I'm going to do some algebra and combine my two fractions here together. So that would give me 5x minus 5x plus h with a common denominator of x times x plus h. All of that's divided by h. Now I'm going to go again and clean this up. So I don't want fractions and fractions. I'm going to just carry out this division. So we just have a proper fraction. So my denominator would be h times x plus h. And then at the top is my 5x minus, and I'm going to distribute the 5. So it's negative 5x minus 5h. So now after writing this, I can see the 5x's will cancel. Let me move this. So now we got limit h is approaching 0. So we got negative 5h over h times x plus h. So I see the factor of h can cancel. So that now removes that discontinuity that I was going to have. So this is no longer indeterminate. So I can substitute in h is 0, which gives me negative 5 over x squared. So now this is my derivative. So by doing it this way, now I have my general form. So now evaluating those derivatives is just a matter of plugging in the number. So at 2, negative 5 over 2 squared, so that's negative 5/4. At 4, sorry, not 4, but negative 4, it would have been negative 5 over negative 4 squared, so that would be negative 5/16. At 0, so at f prime of 0, this did not exist. It didn't have a derivative because originally, if you look at the function, x could not be 0. It would have been undefined anyways at 0. So there's no way it would have a derivative answer if it were originally not defined. So we wouldn't even say like, oh, it's undefined. It's just there's no derivative, period, because the graph doesn't exist. So if the graph doesn't exist there, how could there be a slope of a tangent line to something that doesn't exist? So then the last one would be pi, which is -5 over pi squared. So that's how we would go about evaluating those.